Welcome to The Explainer. Today, we're going to pull back the curtain on something amazing, how companies manage to pull off the incredibly complex dance of manufacturing.
All right, so here's our game plan. We'll kick things off by looking at the sheer challenge of getting everything coordinated. Then, we'll dive into the core planning systems that make it all possible. And finally, we'll see how they all connect to keep the entire process running smoothly.
So to really get this, I want you to picture a factory, but think of it like a symphony orchestra. Every single part, every machine, every person on the line, they're all individual musicians. So how do you get thousands of parts to show up at just the right place at the exact right time? Because for that final performance, the finished product, to be perfect, every single one of those musicians needs the right sheet music. They have to play their part at the perfect moment. You miss one note, one cue, and the whole thing can just fall apart. That is the orchestration challenge. Okay, so how on earth do you conduct an orchestra this complex? Well, it all starts with the conductor's main score. And in our world, that's called the Master Production Schedule, or MPS.
Now, this is absolutely crucial to understand. The MPS, it's not a forecast, it's not a wish list, it is a commitment. It's the build schedule that the manufacturing team is on the hook to deliver. You can think of it as the official score the entire orchestra has to play from, no exceptions.
Let's take a look at a simple example. See how the forecast, it's all over the place, right? 5, then 8, then 10. But look at the MPS line. It sets a nice, steady, level production of 10 units every single week. That's all about creating stability. Now that projected available row, that's our expected inventory. And look at period 5. We're projected to go negative. This shows us that while the MPS is great for setting the high-level tempo, we're going to need a lot more detail to avoid crashing and burning.
Right. So having that master plan is a fantastic start. But how do you actually tell every single musician, every tiny component, what to do and when to do it? Well, that brings us to the next piece of the puzzle.
This is where Material Requirements Planning, or MRP, becomes the absolute hero of our story. It's the system that takes that high-level score from the MPS and it explodes it into super detailed sheet music for every single part, every nut, every bolt in the entire factory.
Now, for MRP to work its magic, it needs 3 key inputs. First, what are we building? It gets that from the MPS. Second, what's the recipe? In manufacturing, we call this the bill of materials. And third, what do we already have in the kitchen? That's our inventory status.
Okay, let's make this super concrete with a simple example. We're going to build a snow shovel, and our master schedule tells us we need to make exactly 100 of them.
So step 1 is the requirement from the master schedule. It sets our goal. We need 100 finished snow shovels, and they're due in week 10. Simple enough. Now, to build 100 shovels, we obviously need 100 of the top handle assemblies.
And here is the absolute genius of MRP. The system doesn't just blindly order 100. It checks our inventory first. It sees, hey, we've already got 25 of these handle assemblies sitting on the shelf. So it does the math and calculates that our net requirement is only 75. This incredibly powerful yet simple calculation is called the gross to net explosion.
And that calculation creates something called dependent demand. See, the need for 75 wooden handles, 75 bracket assemblies, and 150 nails, it's entirely dependent on our net requirement to build those 75 assemblies. We don't have to guess. We don't have to forecast. We calculate it perfectly.
But it gets even smarter. MRP allows for a really powerful timing technique called back scheduling. See, the simple way to do things, what we call front scheduling, is just to start making everything as soon as possible. But that creates a huge mess and a mountain of inventory. Instead, back scheduling works backward from the due date. It figures out the absolute latest possible moment you can start making each part so that it arrives just in time. This is a game changer. It saves so much money and space. Okay, this all sounds great in theory, but we all know the real world is messy, right? What happens when a musician is late or a supplier's shipment gets delayed? No plan survives contact with reality.
This is why planners build in buffers to absorb the shock. You can think of it like this. They use safety stock, which is basically just a little extra inventory, to handle quantity problems, like if a customer suddenly orders more. And they use safety lead time, which means starting a job a little bit early to protect against timing problems. These buffers make sure that small hiccups don't turn into a total disaster.
Another clever trick is something called time fencing. Imagine the production schedule is broken into zones. The zone closest to today, say the next 8 weeks, is frozen, no changes allowed. This gives the factory a stable, predictable target to hit. A little further out, it's slushy. Changes are possible, but you have to negotiate. And way out in the future, the schedule is liquid, totally flexible. It's a brilliant way to balance stability with flexibility.
All right, so we've got the internal factory orchestra playing in tune. But that's only half the battle. How does the symphony connect to the outside world? You know, the warehouses, the stores, the actual customer?
Well, that's where our final system comes in, Distribution Requirements Planning, or DRP. And here's the cool part. It uses the exact same powerful logic as MRP. But instead of planning for nuts and bolts inside the factory, DRP plans for getting finished products out the door and into the world.
So if MRP creates an explosion of requirements for parts, you can think of DRP as creating an implosion of demand. It looks at all the different warehouses out in the field, gathers up all their needs, and then rolls it all up into one clear, consolidated demand signal that feeds directly back into the factory's master production schedule.
And just like that, the loop is closed. The entire system is connected. DRP tells the master schedule what the market actually needs. The master schedule tells MRP what the factory needs to build. The factory builds it. This whole system ensures the company is making exactly what customers are buying, keeping the entire supply chain symphony in beautiful harmony.
But this leaves us with a really interesting question. In a world that is just constant disruption, is a perfect plan even possible? Or is the real goal to have a system that's perfect at replanning? Because that's the true power of these tools. It's not about creating one flawless plan. It's about having the visibility and the intelligence to adapt instantly when that plan, as it always will, changes. The goal isn't being perfect. It's being perfect at adapting. Thanks so much for joining us.